Thank you for joining the January 10th, 2019 VOLTHA call. Today we will be going over some presentations and discussions. We have a couple topics lined up for today. We post the recordings to YouTube, so keep that in mind with what you're sharing during those presentations and with the related discussion. And with that, I think we will go ahead and start the meeting. I just want to double check. Can everyone see my screen at the moment?
I can see it.
Okay, great. Thank you. So our first topic for today is going to be on Multicast, and Igmp has prepared an overview or a recap of what was done for VOLTHA 1.0 proof of concept. We also have a presentation planned at a later time. We'll firm up the date for that with Sarisha from Nokia. We'll give a presentation related to that as well. We were hoping to have them both at the same time, but we had some schedule conflicts. So today it will just be the presentation from Igmp. This will be scheduled at a later time. And then we will be having some discussion related to VOL 1022. We had a breakout session the other day. And then as a follow-up to that, Igmp has a slide that he has on sequence diagram, and then Jason also uploaded one this morning. I haven't talked to him to see if, Jason, I think I see you on the bridge now. If you're prepared to go over, discuss your slide with the group today, then we can do that as well. So I probably have Igmp go first, and then we can move to your slide if you're okay discussing that on today's call. And then the final item on today's agenda is some schedule planning for the next VOLTHA lockdown. So Sean wanted to bring up some discussion topics related to that. So that should just take a short time, I believe, at the end. And let me see. Okay, I think that covers what we need to for the planning on the agenda. We do have a reminder here that there are a few items waiting in Garrett. We've got a little over a week left for this sprint, so please keep JIRA up to date. And if there are items in Garrett waiting for your review, please try and get to those shortly so that we can move those items forward. And with that, Igmp, let me check with you. Are you ready for me to give you presentation, right?
Yes, Julie.
Thank you. Okay, you should have the controls in a moment. And we can see the slides.
Yeah.
Thanks.
Okay. Yeah. So the agenda is to go through what was done for the AT&T POC regarding IPTV demonstration. Right. So I've prepared a few slides which talks about what was done and specifically the use of the Igmp Proxy ONOS app, how that was used to have the IPTV services running. So, so when we talk about the IPTV service in the AT&T network, right? So what happens is as soon as you turn on a channel, the first few seconds, I can't recall exactly how many seconds it was, but it was around 15 seconds of the channel data is streamed over unicast. And only after that time elapses, does the channel actually switch over to multicast data. So basically after that, the RG sends out IGMP join asking the network to stream the data over multicast. So basically this is the instant channel change functionality. This is to avoid too much of joins going into the network when subscribers keep flipping channels. Right, and as soon as the subscriber goes out of a channel, IGMP leave is sent by the RG. So, so before we go ahead, so there would be other participants in the meeting who would have experience on this, and if you want to share any comments or opinions, please do so. So basically, it's more to do with the IGMP messaging, right, which will basically start the flow of multicast traffic in the network. So there exists a specific application on ONOS, which is called as the ONOS Igmp Proxy App. So what this does is basically does the proxying of the IGMP messages towards the BNG or the upstream IGMP router, as well as this does set up the IGMP snooping at the OLT, right? So as soon as this app comes in, right, so it installs, so actually it's not the IGMP app which installs the flow rules for trapping the IGMP messages from the OLT. It's done by the OLT app. So as soon as the port up, so I have some message sequences later, sorry, where we will go through that, but let me just go over the text here. So as soon as the port is added, IGMP trap flow rules would be installed on that port, asking VOLTHA basically, or the OLT, to send any IGMP messages received from the RG to this IGMP Proxy App. And what this app does is that for a particular group, for a particular multicast IP address or a group, when it receives the first join, it proxies or sends that join to the upstream IGMP router. And on subsequent joins, it does not do that. So basically, it sends only one join for a particular group. On the other hand, for leaves, it sends the leave towards the IGMP router only once it receives the leave from the last member of the group. So it maintains data of which all ports, logical ports or subscribers are currently engaged on which channels. And from that map, it can figure out that, okay, this is the last subscriber of that group. And we need to send IGMP leave to the upstream router to stop the traffic. So because it is doing the proxying, it also needs to do have a courier functionality, right? So it does a periodic query, and right now it has support for IGMP group specific queries. So it queries on all the ports that joined at regular intervals. It also has support for IGMP fast leave. And the current implementation supports IGMP v2 and v3 towards the RG. But it sends only, it talks only IGMP v3 towards the upstream routers.
Hey, Amit, sorry, I joined late. So yeah, I think these seems to be the use case for AT&T very specifically. But so for other service provider, we do, we also want to know whether that's the approach we're doing. So I think the Bjorn is coming up, and then the Third Telecom is around. So maybe, yeah, I think this basically match with the AT&T use case, right?
Yeah. So Sean, yeah, we are actually, I'm specifically talking about the AT&T what was done for the POC, right? So
right,
it should ideally be exactly, yeah.
Okay, great. Thank you very much.
I mean,
so,
I have questions.
Yeah.
Sorry. So can you go back?
Yeah.
Okay. Yes. So I heard that from the Broadcom. So currently the SDK does not support IGMP group IP address now. So you want to, if you want to implement the multicast group IP address, it will be fair in the Broadcom SDK now. So there is a problem in this SDK.
Sorry, Jason, maybe either my connection is bad or something not great on your side, but I didn't get the problem correctly. I understand you're talking about some problem in the SDK, but can you repeat what exactly is the problem according to you?
Also, I just I just provide the information from the Broadcom SDK, support multicast the group IP address. So before that, I have asked the Broadcom engineer for multicast group IP address as IP address support. So and the Broadcom engineer feedback me, and this and the Broadcom SDK, and we use this SDK does not support multicast group IP address now.
So I think there is a when we configure IGMP support, right? There's a range of the range of the the channel addresses. So like the 239 dot something dot something dot something. So you have the range address for the multicast and unicast. So I don't know. One thing I don't know is I also need to find out whether the SDK need to support it, or is something filtered out of the ONOS app or something like that, or Jason?
Yes, I'm listening. Yes.
Oh yeah. So yeah, I think that's a good question. And Jason, do you have the CSP open to the Broadcom?
Yeah.
Or you just talk directly?
Yeah.
Sean,
I had use the multicast command for the standalone testing in the OLT. So I asked some command from the Broadcom engineer. But I want to use the multicast group IP address and set to the Broadcom the chip functionality. But the Broadcom engineer feedback me, and this currently Broadcom SDK does not support the multicast group IP address for as chance you said a range IP setting. So maybe we need to confirm to Broadcom SDK, maybe next release can support this function.
Okay. Amit, you try to say something? Okay. Amit, are you still on?
Yeah, hello.
Okay.
Yeah, hello,
hey,
Sean. Am I audible?
Yeah, I think George Best. The source IP.
Yeah, I'm here. I was off doing something.
Oh, okay. No, that's
what can I do?
No, that's okay. I think let's about the multicast the channel IP addresses. I just don't know whether it's on the OLT side or it's on the BNG side. But anyway, that's my own question. I'll find out later.
But I'm sorry, I missed part of your question because I had a connectivity problem. You were trying to figure out what?
No, I will ask you off the table later.
Okay.
Amit, so if you may have any comment or something like that, or we can continue. But with the Broadcom SDK support of the IGMP IP address range question, we need to proceed to ask some question.
Yes, Sean. So on that, the only comment I wanted to make was that we were investigating on supporting the same use cases on using the ASF VOL16, so using BAL. And whatever our investigation shows is that BAL has everything that is needed to have these use cases implemented. Now, if the question is specifically on the multicast address range, yeah, we did not go into that depth to check what is the exact address range it would support. But I think overall, whatever functionalities are needed are all present in Val to have this use case running as of today.
Okay. Great.
And
Thanks.
this is Val to, yeah.
No, I think
Yeah,
this is something we need to clarify a little bit. Okay. So, but based on your previous investigation, do they support like a range configuration, or you have to enter IP address separately?
No,
So
it is. I don't think it's as an, at least what we tried out was to have a specific IP address configured, a specific multicast IP address.
Okay.
So
configured.
multicast group IP address is like you use the set-top bus changing some channel.
Range.
So this every channel is a multi-group IP address.
Right.
So Sean,
Yeah,
I can
correct.
forward. I can forward I talked to the Broadcom engineer communication, ask for the question of the multicast group IP address. I can forward this email to Amit.
Definitely.
Shine.
Sure. Yeah, I think that'd be great. And I think also, I'm sorry, one of the AT&T also requirement is we need to be able to support 4,000 IGMP channels. So that's one of the Bill Hurst requirement also. But anyway, so Amit, you can continue. If anybody else has any question?
Yeah, I have a question. It's Daniel speaking from Norfolk. Can you go back to the previous slide? Hello.
I mean, back to the yeah.
So the bullet number 4, you are saying that the proxy need to send periodic query to all the port. What does that all the port mean? Is this a PON port or is this a UNI port on the ONU?
It's the logical port as seen by ONOS, which ultimately means it is the uniport at the ONU.
So you send unicast, you will send the IGMP packet as unicast messages, right? You don't use multicast message channel.
No, the IGMP messages would use a gem port which is configured as unicast gem port. Yeah.
Okay, thank you.
I mean, is that the same channel as the channel? Is that the same gem port, same mechanism as the channel changing?
Yeah, the mechanism is the same, but for the gem ports, I think they would be different gem ports. Again, it would be operator defined, right? But I think with AT&T's use case, IGMP has a different p-bit than the ICC traffic. So they would be on different gem ports. But I think the point at which the POC was done, there weren't support for multiple gem ports, so everything was running over a single gem port.
Okay. Yeah. And okay, good. Okay, let's keep going. I was asking about that, and the on-demand type of but that's not multicast. Okay.
Yeah, there may be some scalability issues with that. We probably should look at that. I guess because the IGMP proxy app ONOS only knows about the the end uniport. I guess that's all it can query on. But I think it's going to become very unwieldy if we have to pull every single uniport from the IGMP proxy app. But I guess that's disaggregation for you. Okay.
Yeah.
Okay. So let's move on. Yeah. So here I have pictorially represented the same thing. So after the logical port is created at ONOS, so this information is conveyed to ONOS, right, where the port add open flow message, basically the port status with port add. So the flow rules for IP unicast get added at VOLTHA. And along with that, flow rules for IGMP packet in get added to VOLTHA. And so VOLTHA goes ahead and configures the OLT and ONU for these flow rules, right? And so at this point, we have flow rules which will enable us to pass normal IPv4 traffic, as well as if any IGMP packet comes in from the ONU or RG/ONU, it would be trapped to ONOS. So as soon as the end subscriber, say, turns on the TV or changes a channel, the ICC instant channel change feature would come in, and unicast stream would start flowing from the upstream, wherever is the media server, through the BNG. And as soon as the configured time, which I thought was 15 seconds, elapses, the RG tries to switch over to multicast, and while doing so, it sends the IGMP join. So the IGMP join goes to the ONU, and the ONU has already been provisioned over the flow rules along with the OLT to send the IGMP join to the OLT. OLT has a flow rule to trap this packet, so it delivers it to VOLTHA, and VOLTHA goes ahead and delivers it to the ONOS Igmp Proxy App. So as we spoke about, the proxy app does the proxying, and let's assume that this is the first join for this channel or multicast IP address. In that case, it sends it to the BNG. So here I have just shown a straight line from the Igmp Proxy App to the BNG, but in reality, the Igmp Proxy App has two ways by which this message could be sent to the BNG. One is if ONOS is working with a SDN switch, then we could specify the port on the SDN switch through which the BNG is reachable, and the Igmp Proxy App would use that port to do the packet out. That is one of the options that can be configured. The other option is that the Igmp Proxy App would do the packet out using the NNI port of the same OLT from which the IGMP join came. So it goes through VOLTHA down to the OLT and does a packet out on the NNI port of the OLT, and via that path the IGMP join can reach the BNG. But here, just for simplicity's sake, I've just drawn a straight line showing that using either of the two paths as configured, the IGMP join reaches the BNG. So,
Amit,
so once the BNG,
when you say leaf switch here, that's basically the top of rack switch, right? That's the switch you're talking about, whether that leaf switch is the SDN switch, or if it doesn't understand SDN, then the packet, you know, the join packet go back to the OLT and then go out, right?
That's correct.
Okay.
So what I have not shown here in the picture is that so before it sends the IGMP join to the BNG, the Igmp Proxy App is going to come down to VOLTHA and OLT, basically VOLTHA, and install some flow rules which would help the OLT to do the IGMP snooping and stream the multicast data to the correct PON ports. We will look into those flow rules in the upcoming slide, but it should be just after it receives the IGMP join. So I have not shown that in the picture here. So so carrying on from when the BNG receives the join, so the BNG sees the IP address, multicast IP address, and starts sending the multicast data on that for that multicast address towards the leaf, and it uses a particular vid for the multicast data, and in this case it was VLAN 4000. And from the leaf switch, it comes down to the OLT, right? And from the OLT, it goes down to the ONU, and the ONU strips the VID and sends the multicast data down to the RG. So what happens in the OLT and ONU? Let's look at it in the next slide. Yeah, so
Amit, sorry to interrupt. This is Vikas. So I have a question. So in the previous slide, how is multicast data getting transferred from OLT to ONU? Is it a XGEM port or is it some special multicast GEM port?
It's a multicast GEM port.
Okay, thanks.
Yeah, so so the first flow rules, what I am showing here are the flow rules which are for trapping the IGMP packets. So you can see 128, I think, is the NNI port, and 257 is the UNI port of the ONU. So it says if import is 128 and IP proto 2, which is IGMP, send it to controller. Similarly, if import is 257, which is the NNI port, so for IGMP packets coming from the upstream, right, because it's doing a proxy, so when the upstream querier sends IGMP messages, the Igmp Proxy App responds to those, and that's why it needs to trap the packets that are coming on the NNI port as well. So these are the two flow rules that get installed right at the in the beginning. So one of them is as and when a new uniport comes in, and the other is when the OLT comes in.
Hamid, so when the packet, the IGMP packet coming from the NNI port, the app in the ONOS, the multicast app in the ONOS will remember the port, the NNI port. So it will send the join and leave later on that port?
Yes.
Okay, thanks.
Okay, and the next one is the flow rule that I was talking about here, that as soon as the ONOS Igmp Proxy App gets the Igmp join from VOLTHA, it installs this flow rule. So if you look at the flow rule, it says import is equal to 128, right, which is the NNI port, and VLAN width is 4000. So as we saw that the multicast data is coming down on VLAN 4000, and the IP destination is, for example, this particular channel. In this case, the treatment is group 1. So per multicast destination address or per channel, a new group is created at ONOS, and ONOS targets all the packets for a particular destination to that group. So this rule, along with the group information, is what gets installed. Right after we get the IGMP join. Right. So and if you look inside the group.
So yeah. So when that group is okay. So if someone it's only one flow for the whole OLT. You're saying once the first one joined, then this flow will create, right? What about a second channel start joining? Will they create a different flow, or did they just utilize this same flow?
No. So for the second join, it will still be the same flow. No new flow will be created. Only the group would get modified. So
the group will be bigger. Yes.
Yeah. So the treatment of this group, if you look into this, that's what is listed next, is that anything that comes onto this group right now, the action is to output into 257, which is the only single subscriber who is watching this channel. So if one more subscriber tunes into this channel, right, so the flow rule with the IP address that's already there, so it need not be installed again. Only the group would be modified, and say the other subscriber is port number, say 260. The group would be modified, and output to 260 will also be added to the group. So henceforth, after that, any packet that comes to this would be output on both 257 and 260.
But if the second channel is, let's say, what I'm asking is the IP address and the group are one-to-one mapping, right? So
that's correct.
So yeah, for second channel content, if that's a different IP address, then you will create a group 0x2.
Yes,
and
that's
then
correct.
whoever join, whatever Uniport join, then will become part of that group. Okay, I got it. So
Yeah.
potentially, if we have 4,000 channels, which means potentially the map, the ONOS need to support 4,000 group, and within 4,000 group, you can have. I'm talking about for fully populated system, then you're going to have 16,000 ONUs. So potentially you're going to have 16,000 ONUs per group. Is that correct?
At a point of time, I don't know if one ONU can be participating in multiple groups, because I think a subscriber would be watching only a single channel, right?
Because you have multiple set-top box, right? So I have
Okay.
I can and multiple TV, so people watching different channel, different content. Then you have different channels, right?
Yes. So yeah, you're correct. As many channels are there, those many groups and flow rules would exist at ONOS, and as many people are, or as many subscribers are watching the group, those many entries would be there in each of the groups.
Right. So let's say we have the what's that? World Series, right? Not World Series. What is coming up? The
Olympics coming up.
The football, right? So potentially everybody watching the same channel, but only one group. But under the group, you have a lot of the Uniport under it. Okay, got it. So potentially we do need to look at the scalability of this ONOS app.
Yes, we do need to do that. But again, each of these are on a per device basis, right? So it needs to scale to the maximum number of subscribers that potentially could be on a single ONT.
Right.
So where would authorization to watch a particular channel be enforced? Would that be down at the ONU, or is that at the the ONOS app, I guess, or even the media server?
I think the BNG, right? Depending on the user policy, I think it's the BNG controlling whether the user can access certain channel. I don't know.
Yeah,
but the BNG doesn't see all the joins, right? It just sees the first for a channel.
So the question is, if a subscriber does not subscribe this package, right? They are the bronze package, so the certain channel cannot be viewed. So how to prevent them from joining those group? Join the group to the gold.
Right. So I mean, it could either be done. I think the ONU itself can have a range of allowed channels, but then that involves configuring the ONU. Or it could be done, I guess in this case would be the ONOS app could have the rules to say whether someone can see a channel or not. Right.
Julie, do you remember whether something the RG side control?
It's not the RG. It's for us at least. It's through the set-top box and permissions there, and with the media room, I believe. So you and I can talk afterwards for the AT&T.
Yeah, so there's the EPG, right, that gets downloaded to the set-top boxes, it's not that secure, right? But yeah, so I mean that could be done as well.
Yeah. So it may be a discussion the group wants to have on if we want to add in support for that for this model, for doing some sort of controls beyond kind of, you know, at least how AT&T is doing it on the legacy version today.
Well, this is a very good discussion, actually. So where the policy, so that's part of the policy enforce where the particular user can access, right? So it seems like, does the ONOS app has the capability to enforce that policy?
Yes, so Sean, if you want to do it on ONOS, I think it should be pretty doable, right? If you have a subscriber profile which says what are the IP addresses / channels that subscriber can view, the ONOS app can do the filtering out there.
Yeah. I welcome comments in the future discussion comments from other service providers. I think the DT and TT, we all support IGMP proxy multicast. So let's think about this offline. But the policy enforcement of the access, I think that's definitely a topic we need to talk about. Okay.
Yeah.
Sean, do you have any information about the multicast requirement from other service providers besides AT&T? Do they need the multicast at all?
Can you say that again? Sorry.
Do you know that other service provider need the IP multicast services, or just AT&T?
The IGMP application it is for the IPT the multicast.
Yeah, I know. Whether the other service provider like Telefonica or Deutsche Telekom need those multicast services?
Yep, more than AT&T. No, AT&T is not the only one.
All right, thank you.
Okay. Yeah, so carrying on, so the next 2 points, what I've just mentioned is whatever we spoke about and whatever is needed to implement this. So all of that, the functionality that is needed exists in the VOLTHA core, but the functionality that is needed in the adapters that needs to be built. So adapters should handle these flows that we are seeing here and program the OLT accordingly. So as of today, the ASF-VOL16, the old ASF-VOL16 adapter, or the current Open OLT adapter for using ASF-VOL16 device does not support handling these flows or support multicast, but it needs to be built at some point. And as I said, we were doing some investigations, and maybe we will look into getting into an implementation at some point of time.
Hi, Amit. This is George Montano from NorthForge. I have a question because we're working also on this test automation, and we were considering implementing a multicast test case at one point. Then we realized that the support was not quite there. So can you comment about the support in PONSIM right now based on what you know? What's the current extent of the support?
As far as I know, I don't think there is any support in the PONSIM on multicast.
There were a few tests listed in the in some of the VOLTHA tests repository in the GitHub, I thought. So those are more for future.
Yeah, maybe I'm not the best person to comment on PONSIM, but at least to the extent that I know of, I don't think it's being done right now. Anyone else wants to comment on that?
The Ken is on the call, right? I don't think the I think that's one thing I wonder whether the BBSIM need to do, because
I think a while back, Juno made some changes in the bond sim around multicast, but I don't think it was complete. Or either it was, I think it was just like more like a set up the background, but not much casting has been done in that area.
Okay, thank you. So what we've looked at here, it's not supported by PONSIM either.
Yeah, I don't think so. I've never tried.
Okay.
I doubt it.
Okay, thank you.
Okay, that's about it. What I have for this topic.
Amit, is this so? You sent out this presentation already, or?
Yeah, Sean, I had sent it out to you.
Okay.
I didn't
Yeah.
post it.
So it's the same one, right? Okay.
Yeah.
We can post it on the wiki also. Hey, I think this is a very good first discussion. You know, and I think I reach out to the last year's participant regarding to the IGMP stuff. I think Nokia will come back to have some discussion also. I think we have some. Yeah, the Srisha will join us at a future point. But I admit, I think this is a very good kickoff of the IGMP discussion. And thank you so much for definitely show how much time you have put in on this thing. So thank you.
Thank you.
Anybody has any other questions? And I was still.
Go ahead, I'm sorry.
Oh yeah. So Julie, back to you.
So actually, we're going to go back to Amit for the next topic as well. And so the next item was, so we did have a separate meeting to discuss Vol 1022. And as a follow-up from that meeting, Amit has a proposal that he put a slide together for the reporting the ONU Registration ID to ONOS. So what I'd like to do next is to go over that with the group. So this will be the first time I think that the group has seen that slide. And then if we have time after that, then I saw Jason did post a sequence diagram for the, I think it was for the ONU activation on the JIRA issue for Vol 1022 as well. But I'd like to start with Amit's presentation. Sean, just a quick question for you. How much time do you need at the end to talk about the VOLTA lockdown schedule?
I can go through that with the VOLTA discuss, so I don't need to address it here.
Okay, so I think we'll have a few minutes at the end, but in case we don't, then we'll defer that one to VOLTA discuss. Okay, thanks.
Julie, sorry, I stopped sharing my screen. You need
That's
to
fine.
give me the
I'll make you presenter again.
Yeah.
Actually, it's still showing me that you're presenter. You may just need to reshare.
Okay.
Or I can...
Got it. Yeah.
Okay.
So is my screen visible?
Yes, it is.
Okay. Yeah. So so we had a discussion between a few folks. I think that was yesterday, and so the problem that we are trying to address is how do we send the registration ID of an ONU, which is 36 bytes in length, to ONOS, right? So as of today, the serial number goes to ONOS, and the ONOS app sends it to further upstream to not-bound systems to authenticate and authorize that serial number. But if the registration ID were to be used, then it would need to be present at the ONOS OLT app. And so the question is, how do we send it? So just for the understanding of everyone, the mechanism which is used to send the serial number of the ONU as of today as we can see in the diagram, is the OpenFlow port status message. When we give a port added event on that, the name of the logical port is made equal to the serial number of the ONU. And it is using this mechanism that the serial number is conveyed to the ONOS app. So, so what we're trying to say here, is that although the specifications say that the registration ID of an ONU could be queried by the OLT when it is not able to authenticate it using the serial number alone. What we are proposing is that that VOLTHA always queries both the serial number and registration ID of the ONT, right? And once it gets both of them, the flow remains the same for the serial number. So as is being done today, the logical port gets created. So an open flow message goes to ONOS with the port added event, right? And the serial number is reported in that as the port name. And when the ONOS app receives this, it posts an event on the Kafka bus. For not-bound systems to consume, the event would be a uni added, and this would contain, the event will contain the serial number of the ONU. So, so after this is what the proposal is, that what we are saying is that we introduce a new open flow experimenter message, which can carry the serial number, registration ID, and along with that, the PON port on which the ONU was discovered, because I think that is also an information that is generally used by not-bound systems to authorize if the ONU is connected to the right location or not. So we use OpenFlow experimenter message to convey this information, right? And once this is received at the OLT app, it posts a similar event to the Kafka bus. It would still be a uni-added message event, but along with the serial number, it would have the registration ID and the PON port also. So from a not-bound system's perspective, for use cases where only serial number is used, it could still work with only the first uni-added event and ignore the second one. But for not-bound systems who do need a registration ID, they would act only on the second uni-added event, and they could ignore the first event. So that is what the proposal is. But there are a few questions which I don't have answer for right now, and we would need to dig deeper and get help from maybe some of the folks to figure out more on that. So the first question is, if you talk about sending out an OpenFlow experimenter message, so this has to be encoded and sent by the OF agent. So we need to devise a mechanism or figure out a way as to how this information, the serial number, registration ID, and PON port, are conveyed from the adapter through the core, finally landing up on the OF agent, so that it can be encoded and sent to ONOS. That's the originating part of the problem, right? And the second part is, which we again need to figure out, is once this message, experimenter message, is received at ONOS and is decoded, how does it get conveyed, or how does it get sent out to the OLT app? Basically, it would finally need to land up at the OLT app. So these are two opens which we need to figure out, and depending on how it goes, and depending on what the community thinks about the proposal, we need to see how we take it forward. Any questions?
Python would probably be used
So I have question is the regarding to the OpenFlow implementation, how to implement in the ONOS. Can you provide us some more information for that? Hello?
Yeah, Jason, I think what you're asking is how do we decode those messages in ONOS, and is that what your question is, or?
Okay. So regarding, I saw I saw your picture is OpenFlow implementer extension in the ONOS. Can you provide more information for that for the OpenFlow implementation? Can you provide more information?
Yeah. So I don't have the OpenFlow specification handy right now with me, but if we open the spec, and yeah, so A54, section A54 is where you would find this message. Section. Give me a second, but yeah, it's there in the specification, section A.5.4. Yeah. So if you see this the experimenter message is defined as follows. So we have the experimenter type, and then you have experimenter defined arbitrary data. So that's where we could fill in more data.
So as I knew that it's implementer use this extension only the flow table, action table, and matrix table. So if you want to store the version ID, series number, so I don't realize that we can store the version ID, series number into the action table, flow table. So there's a why I asking for the experimenter can do store the series number and registration ID into somewhere implementer structure. So can you provide them more detailed information for that?
Yes. Yeah, so Jason, what my understanding is that experimenter is an open flow message in itself, right? So we could use this new message altogether and encode the data that we are talking about inside of this message. It's not a field, one of the existing messages, but a new message in itself.
So okay. Sorry, I don't very much catch your noise. So can you speak again? Sorry.
Yeah. So what I was trying to say is that so if you look at section A.5.4 of the 1.3.0 specification, it says that experimenter is a message itself, right? It's an open flow message. So we could encode the items or data that we want inside of this message. I think what you were talking about is experimenter fields within some of the existing messages, but rather what I'm talking about is an experimenter message in itself that we could use.
So you mean the control and between the controller and switch, right? Yes.
Yes. Yes. So the switch could send an experimenter message to the controller, which could carry the data that we are looking to send.
So and depend on you define the parameter, you can get him from the detailed information from the switch.
Yes.
Okay.
Yeah, I've got a basic question. Why do we even need an experimental? It looks like we're tying the VOLTHA application tightly into the OLT application with a custom message. Can't either a Kafka message be generated or an alarm containing the registration ID and something northbound of both ONOS and VOLTHA, such as NIM or whatever the operator happens to use, intercept that message and work off the registration ID if needed? It seems like we're trying to force more OLT behavior into the VOLTHA core on how this thing comes up.
Yeah, Chip, definitely that is possible, and I think in certain cases people have been working around with options like that, and I think that's a valid solution. But with the bottom-up approach that we are using right now with OpenOLT and the entire control coming to ONOS, I thought it's an architectural choice that we give the control to ONOS, and from there on, our northbound systems take it over. So I think it's more of an architectural choice, right?
Yeah, it just seems like this could be. I mean, I think it could be just much more simpler if we just ignored trying to add custom OpenFlow messages, because most everything will have some kind of northbound if they need to go back, and that can actually control whatever the application is. It might not be the OLT application, and it might not even be ONOS.
Yeah, I seem to also. I know you know, of course I don't know these details, but it seems like I just feel like the sequence of event of this is, you know, experimenter. I don't know. It doesn't feel very. How's that? It feels like you have multiple ways to try. I cannot say anything. Sorry, erase my recording. But yeah.
I kind of agree with Chip there. It's in the sense of when we look at even before, when we're using the serial number as a port name, it's really a workaround where we put the serial number in the port name there, because there was no such field available for serial numbers. And now we have a new field, registration ID. So what we do with that, and what is tomorrow there's another field. So it's more scalable and better way would really be to send that message over Kafka and directly from VOLTHA, and instead of trying to create custom messages, and eventually maybe we'll have to extend that custom messages to accommodate new fields.
Yeah, and just a small point, the farthest box line to the left should actually probably be the ONU device adapter, since it's the one that receives those messages over OMCI. Or a combination between the OLT and the ONU.
Yeah, I just put in the OLT because VOLTHA talks only to the OLT, and the OLT is the guy who is getting the serial number and registration ID over PLOM, right? So yeah, it could be OLT plus ONU. I could have put it that way.
And one question: how do you expect, for example, the VOLTHA app, the ONOS app, right? How do you expect determine whether this service provider require experimenter message, and other service provider doesn't need that?
Yes, so Sean, so that's what we have tried to put at the top left corner, saying that irrespective of what the operator wants to use, right, VOLTHA would always extract both the serial number and registration ID from the ONU device. So in cases where registration ID is not used, an ONU has to always support a registration ID, although it might be blank or empty. So it would return back an empty registration ID, and that is what would flow upstream, right? So if to summarize it, if an operator does not use registration ID for authorizing its ONTs, then the registration ID would be just empty. Yeah, so Chip, I do agree with your comment, and even Ken pointing the same, that why not use Kafka to convey this information? That definitely is a workable solution, but it depends on the architectural choices we want to make. Is it okay that we don't have the complete control at the OLT app? And maybe we should circle in with some of the guys like Shad and Saurav, who worked on the OpenOLT and proposed the bottom-up approach, if they also are in concert with, and in agreement with using Kafka as the mechanism to send out information like this. But even if we were to use Kafka, do we think there should be a separate channel or channel/topic in Kafka, which should take care of this, and not the same ones as exists as of today? Because these are events which are much different from the alarms and KPIs that we write onto Kafka as of today.
Well, this of course it will be different topics, but it's also depends on like you mentioned, like how the OLT app is designed. But basically, like here you have ONOS and /OLT app together, but I believe it's already like event driven now between the two of them. Like OLT app will listen to some events whenever something happens. So I think it won't be stretch to add new events there. But then, like you said, then again, we need to consult with the folks at ONF to make sure it works.
Yeah, I think right now this port status message is a thing that notifies ONOS that a particular subscriber basically has arrived, right? With service providers that don't use serial number, and they only use registration ID, I mean, that you kind of lose that capability, right? Over the OpenFlow port status. I mean, because they wouldn't use the port status port added with serial number, because that means nothing to their backend systems. They really need registration ID instead of serial number. So there's a tight coupling between this OpenFlow port status message and some operations that occur at ONOS, right? I mean, I guess we're kind of taking away that tight coupling, and now we're saying, okay, we're just going to use Kafka essentially to convey this essential information about the subscriber. I guess that's a choice. I mean, I guess we're saying Kafka is secure, right? I mean, so I guess I'm just making the statement that for an operator that doesn't care about serial number, then you lose the functionality that the port status message, the first one, is giving you, right? They really want registration ID instead of serial number, or both, basically.
I think you'll still have the port status being sent up. Like a port added message will still be sent up to ONOS.
Right, but ONOS can't derive the subscriber information from serial number.
Why do they need to derive the subscriber information?
Well, so that the relationship between the subscriber and the ONU port now is given by registration ID. So it could be in the US, it might be, let's say, a phone number, for instance. So the registration ID could be a phone number. So once the phone number is notified to ONOS that, hey, this phone number showed up as an ONU on my PON, then they can look up with that phone number all the subscriber related information for that particular subscriber. And currently for AT&T, that occurs based on the serial number. So I can use a serial number to look up what the subscriber information is. But other operators only use registration ID.
Or both, right?
Or both, but mainly the relationship is done by the registration ID because that's independent of any particular ONU that might be installed at a customer location.
Okay, yeah.
Is it ONOS that lookup, or is it a different app within ONOS that does that lookup?
Well, so the subscriber record would have a registration ID instead of a serial number. Right? So the relationship between a particular customer and the data in that subscriber status record is looked up based on serial number in one case, and it's looked up based on only registration ID in another case.
Yeah, I understand, but which component does that look up? Is it ONOS per se, or an app that resides on top of ONOS, or an ONOS driver?
Well, right now it goes to the status, right? So it could be off system, or it could be cached locally, right? So the I guess VOLT, I guess, would look it up and then do the configuration based on the information in the status record. But to get to that information for an operator that only uses registration ID, it needs only registration ID.
Oh,
okay, so I guess the flow is changing. I guess if we say we're going to use a Kafka record, a Kafka event, right? So I guess, which I guess is okay, but it's just, I mean, the flow of how this operates is going to be slightly different, right? Because I guess someone's going to have to be listening for the event saying that the registration ID showed up, and then do the same thing it would do if it got the port status message for a serial number based operator.
Well, in one sense, if we wanted to keep it sort of simplified, if you had an OLT application that could also listen to the bus and be configured to automatically, to do it off the registration ID at that point. So either the OLT application could look into a SADIS equivalent registration ID database, or a northbound system that would get the same Kafka message of the registration ID could tell the OLT app to allow or not.
Yeah, I think whatever we decide, the mechanism should apply both cases, right?
So, and I have another proposal regarding to the registration ID with the ONOS, and can I show my screen to point another proposal?
Sure. So I was just going to check if there are any last questions for Amit on what he was presenting before I give you control. Any last comments or questions to Amit? Okay, Jason, I'll give you presentation right, and you should have them in a moment. And I
can you see that?
Yeah.
Wait.
So.
And we can see the sequence diagram.
So this is my another ONU activation with the registration ID to the ONOS. So you can see the ONU component or OT, VOLTHA, ONOS, Kafka. So and between the OT and ONU, we focus on ranging state. So ranging state, we can use the SIS number registration ID. So we based on the broadband forum standard, the TR-156 standard. So regarding to this standard, we can range in the ONU, activate the ONU without the registration ID. If SIS number exists. If you don't have the SIS number, so you can use the registration ID to activate the ONU. So this is standard defined from the broadcast forum. You can check this the standard TR, technical report 156, and for the ONOS, ONOS can do have the getting the SIS number from the OT driver, and the OT driver can support can have the ONU the SIS number from the prompt message automatic. So this is a chipper behavior. So the chipper maple chipper can do this behavior to the agent. So when the VOLTHA get the SIS number, this SIS number can compare with the ONOS. So the VOLTHA can get from the ONOS the SIS number for this ONU. So it can compare the ONOS is authorized. It's authorized on you. It's a match this the SIS number. The next step we can do is activate the ONU, or we can also use doing for the registration ID authentication. So you can see this the block we provided the up and down the block, the up on the block, and we can use the get the registration ID from the VOLTHA, and this actually is get the registration ID from the ONU, not it already can do this job, but it's actually.
So just one comment on this. So I mean, it used to be back in the day that the ONU wouldn't remember the registration ID. So basically, the first time that I install an ONU, I give it there's a registration ID, which in the US was like just a password, right? I mean, a phone number, right? And the first time the ONU would register, it would send up in the password field, it'd send up the registration ID, right? And then the OLT system would then say, okay, I saw this registration ID with the serial number, so I'm just going to remember that. The OLT would remember it, right? Because then the ONU subsequently, if it cycled power or something happened, it wouldn't remember the registration ID it was given, right? And so the OLT had to remember that and then associate that with a serial number. So, you know, after it comes up again, it could use a serial number because it basically got registered with the registration ID, right? But modern ONUs remember the serial number, so it always comes up. Sorry, the registration ID, so it always comes up with and registers with the serial number.
Yeah,
so
that's correct.
So the first time an ONU comes up in both these scenarios, you still need the registration ID in order to be able to associate that ONU with a customer subscriber record. So you still need it in that case, right?
Yeah, but some, yes, you are correct. But some of the vendor ONU and this registration ID is empty. So we need to care about which were the ONU can do different scenario. So we can do this. You can predefine the registration ID in the ONOS by default, and if you don't want me to the registration ID to activate your ONU, so we can change another way to generate the random registration ID and to the ONU and this to the ONU, yeah. To the ONU, on the ONU can the remember remember forever to the ONU. So next step, whatever, maybe ONU reboot the ONU when the ONU and put up, you can use the registration ID to do the range instead between the ONU and OLT. So
yeah,
that's all.
But the problem is the ONOS doesn't know what a serial number is, right? So I can't associate a serial number with a particular subscriber. That only happens when the registration ID comes up from the ONU, because the back office systems of an operator that only uses registration ID does not use serial number at all. So it doesn't know what the serial number of an ONU has been used, right?
So, yeah, but in the standard, the first choice is series number. If you don't have the series number, you can choose the registration ID to activate it on you. So I don't know. It may be some telco would like to change this scenario. So maybe we need to cover different scenario to activate on you. So
so basically, let me just speak this back to you and see if I understand here. So the ONU comes up, gives the serial number to VOLTHA, and then VOLTHA goes and passes that to ONOS. If ONOS doesn't have a serial number, what happens then?
Sean, this is George with BBNMS. Are we talking the top-down or bottom-up scenario on this?
Oh, this is bottom-up.
Oh, okay.
I think right, Jess? This is the bottom-up scenario where a serial number comes in from the ONU and then tries to authenticate it with the ONOS or the back office system.
So we can do up to down scenario. This is up to down scenario. So you can see this diagram. the first behavior is OLT can send the series number request to the ONU, and ONU can response. These are up to down the scenario.
Okay, so I guess I think the question comes from the first line at the top of the thing here. So basically the back office system authorized ONU serial number and registration ID. So I guess the issue with an operator that just uses registration ID is there is no serial number, right? So it's just registration ID is available to match a subscriber, right?
Yeah.
So initially the ONU comes up in this model here and supplies the serial number. That's not enough to associate the ONU with the subscriber record, right? So then there's a request to go and get the registration ID, and the registration ID then comes back, and then that's passed up to ONOS, which then can authorize the ONU. And
what's the difference between a registration ID and a serial number?
Well, registration ID is just some alphanumeric string that is a password, essentially a password.
Okay.
So it's a different choice for each of the registration ID activate scenario. You can see the list of the block is divided to the scenario. You can maybe you can choose the different scenario to activate only use the series registration ID. So this scenario is defined only the program standard. So you can see the first is the activate using activate only use the registration ID is get the registration ID from the OLT. The OLT can send to the ONU, and the request the ID can send back to the VOLTHA. This get the registration ID from the ONU. Another way we can generate random the registration ID on the VOLTHA and send to the ONOS. ONOS can remember forever this the registration ID. Just in case the reporter, you can use the standard registration ID to do the activation. So this is a different scenario for the different ONU.
Right, but I'm not sure that generating a registration ID is going to help, right? Because the ONOS or the status record, the registration ID doesn't exist, or it's not going to match a subscriber, right?
Yeah, yes, and ONOS can remember this registration ID, and just in case the ONU and back to the network, back to the network want to connect to the OLT, so we can and search on the ONOS and get the registration ID. So in the beginning, the ONOS and ONOS cannot have the registration ID by default. So if you have the registration ID, that means this ONU and had activated already before. So I provided this and this the diagram and according to the standard to figure out what kind of what kind of the different thinking in the different thinking in our implementation.
So I mean, it looks a lot like I think Igmp's diagram in some senses, right? Because there's you get the serial number first. You try and get the authorize the ONU at ONOS. If it knows the serial number in the ONOS subscriber record, then it can authorize it and everything can proceed, right?
Yeah.
The next step is, well, if it's a registration only operator, registration ID only operator, then there is no serial number in ONOS. And then basically you go and get the registration ID. And then if you get a registration ID, then you pass it up to ONOS in an experiment or extension field. And you get the response back saying whether it's authorized or not.
Mm.
I'm not sure about about generating registration ID, but I guess in Igmp's case, it's it just would be an unfilled field, right? If the ONU didn't support it.
So if I want to generate a random registration ID, that means that we don't have the registration ID in ONU, so we can adjust from the ONOS have the list record. So it doesn't have, the ONOS doesn't have the list record. We can identify this ONU is a new one. It's a newcomer coming. So we can generate a registration ID.
Yeah, but we don't need a registration ID in that case, because if it doesn't support it, then it has to be a serial number only system, right?
Yeah.
I mean, I can't let that ONU activate if I don't know the serial number and I don't know the registration ID. It has to be just disabled.
And just a time check, we've got about 1 minute left, so we may need to cut off the discussion for today. So I do know that this slide, I believe this is the one, Jason, that you attached to Vol 1022.
Yeah, I have this.
Okay.
Yeah.
And go ahead, Sean.
So I was just going to say, so I mean, it's very, very similar to what Igmp also presented, I think. I guess the other question is, do we want to use OpenFlow to work in this authentication part of the ONU, or do we want to transition to using Kafka, I guess, right?
And so I'm hoping we can continue that discussion using VOLTHA Discuss. And then if we need to, we can schedule another time slot like this for a detailed discussion. But I think we got a good kickoff to the review and good discussion today. Igmp and Jason and all the people who commented as well, thank you for that. We still have a ways to go before we have a solution, I think, for this. But at least we I think have a good start on discussion. So I'd like to propose that we continue the dialogue on VOLTHA Discuss. And Igmp, you may want to send out a copy of your slide as well if you have not done that yet. And then if we need to schedule additional time, let's go ahead and do that on a future meeting. Jason, I'm going to take presentation rights back, if you don't mind.
Okay.
So I should have those in a moment just so I can bring the agenda back up. Okay, so Sean Ying, we'll need to defer the discussion on the lockdown schedule to VOLTHA Discuss, as we talked about at the beginning. And if we need an additional time slot for this, maybe next Thursday we have planned the 2.1 planning, because we'll be kicking off 2.1, potentially, well, we're supposed to be closing out Sprint 12, which was the last sprint for 2.0 that we have planned. We're supposed to close that out on January 18th. So we may need a fair portion of the time on Thursday for the planning, but we may be able to carve out maybe 30 minutes for discussion on follow-up on this topic if we need. So let's see how far we get with email exchange. Any other items for today before we wrap up the bridge? I'm sorry we went over a little bit. All right, I'll go ahead and, oh, yes?
Nope, nope. I just say
okay.
good meeting. Good meeting.
Yes. So thanks everyone for the presentations and discussion. I'll go ahead and stop the recording.